question number 39. In a simple model of a nuclear reactor, 4 neutrons are emitted per fission on average. Okay, the average number of neutrons observed by the control rod is Nc per fission, and the average number of neutrons that are lost through the walls of the reactor is N1 per fission. Okay, and then for any remaining neutrons induced for the fissions, what are the possible values of Nc and N1? So usually, see, if there is one nucleus over here, okay, and now let us say there is a fission which happens. Now this will definitely release some neutrons. He says there are 4 neutrons on average have been released, and then one of these neutrons should go and excite the parent nucleus. Until and unless this goes and excited, the parent nucleus will just be stationary there. Okay, that's what you call as a nuclear enrichment. So minimum there should be one neutron which should go and strike here. There should be a minimum one neutron which should collide. There should be a neutron capture, and after that only it becomes more unstable, and then it will start breaking up. There's a fissionable thing happening over there. So therefore, now what I can say is I can say Nc plus N1 plus 1 should be equal to 4. What that means, what? There are at least some Nc neutrons per fission is getting absorbed, N1 through the walls it is escaping from here, and one neutron should definitely be there. So this should be equal to 4, or Nc plus N, what is this N1? N1, yeah. N1 should be equal to 3 over here. And now, which of this will, in the table will give you this answer. So it can either give you, you can either use C here. Is there any other C? Nc plus N1 here gives you 2, here 4, here 4. So all these are incorrect. The only option available is C here. Okay. So it can be Nc equal to 2, N1 equal to 1. And it's also possible that Nc equal to 1 and N1 equal to 2. Both are possible. But for us, we don't have any other data. So therefore, the only data that we have is the sum of these two should be equal to 3. And that's why I claim that for 39, the answer is C.